Hi class, so this is energy lesson 2 and it's actually part 1 because I made this lesson and I realized it was really long and there was a lot of information, so I wanted to break it into 2 parts. So today we're going to start with part 1. Step 1 is to watch the video and step 2 will be to answer the questions on the doc. All right, so here is the PowerPoint. Energy lesson 2, part 1. We're going to start with a really cool Bill Nye video. If you've never watched Bill Nye, he's really funny and he's an amazing scientist. All right, here we go.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy. The mountains are icy, but they've got motion of molecules. Ha! See, even cold things have heat. Things like snow and icy mountain lakes and glaciers. They've got heat. Anything with molecules has heat. It's just that the molecules in cold things are moving more slowly than the molecules in warm things. You with me? Okay, y'all ready? Sing along. It doesn't matter whether someone feels cold or hot. If molecules are moving, it's something all things got. You know the words now, sing along. It doesn't matter whether someone feels cold or hot. Here's a question. Which has more heat energy? This hot burning match or this beautiful ice sculpture of science? Well, the match is hot, right? Sculpture's cold. Well, they're both made of molecules, right? But which has more molecules? The ice sculpture. A lot more molecules. So although they're much colder than the match, they actually have more heat energy. More molecules, more heat energy. Think of it this way. Suppose you tried to take a burning match and use it to melt the whole ice sculpture. Well, it's not going to happen, right? I mean, the match is going to run out of molecules long before the sculpture. So, more molecules, more heat energy. Ooh, ow, ow. Careful. We broke this one. Bill Nye the Science Guy. Bill Nye the...
All right, I hope you enjoyed that. Bill Nye is amazing, and I even learned something from that video today. So heat is essential to all living things. The sun's energy provides us with heat every day, and other sources of heat are easy to find and use. So what I'm going to show you are a couple questions, and we're going to be talking about them throughout this unit. So I'm just going to bring them to your attention. If you know the answer, maybe talk about it with someone. Why do people need energy? What do you think heat energy is? Where does heat come from? Which do you think gives us more energy, the sun or the earth? When have you wished you had more heat, less heat? What happens to a pot of water when you put it on a stove? Why? What happens to water when you put it in an ice cube tray in the freezer? Why? These are the questions I hope you'll be able to answer after this unit. So these are just some vocabulary. These are words that are important to know, and they're words that aren't used often, but we did use them with our science venture group. So the first one is conduction, the transfer of heat from one object to another, like cooking the egg with light. Kind of when you're on your stove and you have a frying pan there and you're cooking some chicken or cooking some pancakes. So you're transferring the heat from the stove into the pan there, and the heat is cooking it, right? The second word is conductor. So a material that's usually metal that transfers heat electricity or sound from one object to another. So when we were looking at the ice experiment with the cloth and the pan, so the conductor was one of them was a pan and one of them was a cloth. And we found out that the metal absorbed the heat energy way faster. So the metal was cold or really fast, whereas the cloth wasn't. So it didn't absorb the heat energy that fast. So in the end, our hand was really cold when we touched the metal pan, and it wasn't cold at all when we were touching the cloth. The third word is convection. So it's the transfer of heat by movement in a liquid or a gas. So with the food coloring and hot and cold water, remember what was supposed to happen was the hot water, the food coloring was supposed to spread really fast. And in the cold water one, it was supposed to move slower. Another example of this is if you ever steam vegetables. So you're using the steam from the water to cook the veggies. All right, so I actually have some questions and some answers that I think are really cool. So we're just going to talk about them. This is the first part of them. We're going to talk about more on the second part. So is ice water cold because the ice cubes transfer their coldness to the warmer water? It would seem so, but no. Actually, changing ice from a solid to a liquid requires energy. Some of the heat energy in the liquid water transfers to the ice, thus reducing the temperature of the liquid water and raising the temperature of the ice until it changes states to a liquid. Similarly, refrigerators and air conditioners do not add cold, but instead remove heat, leaving the contents colder. So that's why your fridge is actually warm in the back. So don't hurt yourself touching it, but it's removing the heat from the fridge, from inside the fridge. I've heard that heat always rises. Is that the only direction it can move? So what do you think? No, heat does not only move upward. Heat does rise in a gas, such as air, but through conduction, friction, and other forms of heat energy transfer, heat can move in any direction. Are clothes a source of heat? So will putting on clothes, does that specifically heat you up? Clothing does not provide us with heat, but insulates the heat already in our bodies. That is why clothes are said to keep us warm, not make us warm. All right, so that's the end of the first part. So your next job is you're going to actually click on the activity here, and you have 3 questions to answer. What is something that surprised you? What is something you already knew? And do you have any other questions so far about the heat or something you're just thinking about involving heat? So I want you to think about that. If you didn't already know something, you can tell me that in a full sentence. We can use our full sentence skills here. If you have any questions, let me know. Good luck.